All right, yeah, 10. Obviously, if there are things called independent events, then there are probably things called dependent events. Does everyone have a stab at what they think dependent means? It does affect, exactly right. If independent events are two things that happen which don't affect each other, for example, flipping a coin, right? Each flip doesn't affect the other one, then dependent events are where the events are affected by each other. What kind of example can I give for that? Well, if I just go back to that other example where I was picking counters out from a bag, right? I said that I replaced them. So one thing that they'll often say is, oh, what about without replacements? Okay, without replacement. So for example, if you're taking things out of a bag, like counters, and you're not putting them back in, you can see really clearly that the probabilities are going to be affected because, first of all, there's less counters in the bag, and there's less of that color. Yeah, that's right. This is dependent events. Yeah. Yeah, that's right. What's another example? Well, a really great one is raffle tickets. Has anyone won a raffle before? Yeah. Yeah? What did you guys win? What did you win?
I won a sewing kit.
A sewing kit? That's kind of interesting. Yeah? A whole leg of ham. Where was that from? A whole leg. Like for like Christmas party kind of thing or something? One thing that that a lot of people do is they go to the RSL, and they do a lot of meat raffles, right? I don't know if anyone's won a meat raffle before. You won one? Yeah. You won an iPad. Wow, that's pretty good. All right, fair enough. But I think raffles are a great way of highlighting this idea of dependent events because obviously, first of all, if you win, generally they take your ticket out. Okay, they'll take your ticket out. And so also if you win, there's less tickets in the whole pool. Okay, so when we think about dependent events, things that are affected by each other, raffles are a great example of how that happens. Let's just look at this first one here. On your sheets, question 3, I think. So we've got Jesse, and they buy 5 tickets in a raffle with 1,000 tickets altogether. So not a great chance of winning. But there are also 2 prizes. There are also 2 prizes which are going to be drawn. And it says specifically that the ticket is discarded before the second is drawn. Okay? So we just want to be careful when we're thinking about that. What's the probability of winning the first prize? Well, it's the same idea as our usual idea of probability. There's 5 tickets that I have, or Jesse has, and there's 1,000 in total. That's just a 5 out of 1,000. Now you notice for these next ones, they say that what's the probability of winning the second prize, but they have some words after that. Freya, what's the first one saying? Question B.
B.
Yeah.
We can.
Okay. The first prize, second prize, if he didn't win the first prize. So I just want to think about how that's going to be affected, right? So I'm looking at the second prize, but he didn't win the first prize. So I know he's still got 5 tickets in there because he didn't win the first one. How many tickets in the whole pool, though? 999, right? Because someone obviously won the first prize, so that one's been taken out. But Jesse, he's still got a chance. He's still got 5 tickets left in there. So that's how the probability is affected now. It's 5 out of 999. See? Okay. Second prize, I think it's if he did win the first prize. Is that right?
Yeah.
If he did win first. Okay. The second prize, if he did win the first prize. Okay, I want to be careful here. What do you guys think? Yeah, okay. So, because he won the first prize, one of his tickets has been taken out. So he's got 4 left, okay? But there's also less tickets in the pool still. 4 over 999. So, but as in, no, this is just saying what's the probability of him winning the second prize? That's what it's saying. That's what the question's asking. Does that make sense? Yeah. Because so he has 1 less ticket in there, and there's also 1 less ticket in the whole thing. Does that make sense? Yeah. Yeah, so it's true. I don't know, looks like a red bar or something, like a chocolate bar, cherry ripe. Last one. What's the probability of winning both prizes? Now, because here, these ones I was just looking at the individual event. Here, I'm thinking about both of them. How can I do that? Yeah, Frank?
Well, it's 1 over 49950.
Okay, how did you get that? Can you just talk me through it?
Both by 5.
So what am I multiplying? Tell me what's the right.
5 over like, no, I forget. 4 over 999.
Yep.
And then you times it by.
I think you got the right answer, but let me just talk you through how you got it, okay? Remember, this idea of both things happening, so both prizes, I'm really thinking about what's the probability of him winning the first prize and the probability of winning the second prize. But remember, there's two types of second prizes that can happen. I'm actually looking at this one here, right? Because remember, the probabilities are actually affected in different ways. So you have to be really careful there, right? So what's the probability of winning the first prize? Well, that's still 5 out of 1,000 either way. But what's the probability of him winning the second prize if he did win the first prize? Well, because he's got one less ticket in there, and there's one less ticket in total, that's just 4 out of 999. And then if you put that into your calculator, I think you get what Freya got, which was it 1 out of 499,550? 950? Right, it's not a very good chance to win both prizes. So, yeah, very slim chance there. But you can see how that's how we can look at these ideas of probabilities. If the events are independent, we multiply them together. If the events are dependent, we can still multiply them together, but we just have to be careful about how the probabilities are affected. Okay? And that's it.